Hello everyone, in this video we're going to be looking at the Codeforces problem, Maria breaks the self-isolation, which is problem B of Codeforces round 645 division 2. So it's a little lengthy problem, but what is given in the problem is that we have n grannies, and apart from these n grannies, we have one granny who's in a courtyard. So we have a courtyard. Now we want to invite these n grannies to our courtyard. However, each of these grannies have a condition that they will come to the ceremony, they will enter the courtyard only if there are at least the ith, if only if there are at least some grannies present there. So the ith granny will attend the ceremony if there are at least ai other grannies there. And ai other grannies there meaning that either they are already present or they are joining at the same time as she is. So, and for example, it's given n is equal to 6, a is equal to this. So let's just work with the example. So n is given as 6 and the array or the grannies are given as this 154159. So let's just copy it. So these are our grannies and the total number of grannies are 6. Now, initially in the courtyard there will be one granny. So initially in the courtyard there is one granny present, and this is true for every case, and that granny is Maria. So Maria is present in the courtyard. So what we want to do is we want to find out the maximum number of grannies that we can get in the courtyard. So initially there is one granny in the courtyard. Now this ith granny or zeroth granny wants one granny to be present in the courtyard when she comes. And then this granny also wants one granny, at least one granny to be present in the courtyard when she comes. So what we can do is we can call this granny and this granny, and when they come they see that there are three other grannies. Why? Because let's just mark them. So this is 0, 1, 2, 3, 4, 5. So when the zeroth granny come and when the fourth granny come, then the total grannies joining, including the ones there, will be 3. So grannies will be 3. And so zero says the zeroth granny sees that there are three grannies uh, and two grannies. They're not counting themselves. So zeroth granny sees that there are two grannies, and so she joins. Fourth granny sees that there are four grannies, and so she joins. So we call the zeroth and fourth granny together, and when zeroth granny comes, they see that there are two grannies, which is 4 and the one already there, Maria. And when the fourth granny comes, see she's two grannies, which is the one in the courtyard and 0. And so both of them join because 2 is greater than their condition. Now in the courtyard we have 3, which are 0, zeroth granny, fourth granny, and the one already present. Now what we can do is we can ask this granny to come at the same time, we can ask this granny to come at the same time, we can ask this granny to come. Now at the time of joining, how many grannies will be joining? There will be 3 plus 3, 6 grannies will be joining. So for each of them, so for this granny, for first granny, 5 grannies will be joining because total 6 grannies are joining. So for the first granny, apart from herself, 5 grannies will be joining. So for first granny, 5 grannies will be joining, and that's more than or equal to her condition. Now this granny wants 5 to be present, and at her time of arrival 5 will be joining, so that's okay. And for her also, for this granny also, she wants 5 to be already present, and 5 grannies will be joining. 5 grannies will be there. Will be there meaning that either they are already there or they're joining at the same time as her. So we can get 1, 5, 4, 5, 1, all of these grannies. But the 9th granny will never come, because at any point of time we can never have more 9 or more than 9 grannies either joining or there in the courtyard. So what is basically happening here? Let's look at it. So it is simple. First thing, that the number of the grannies which require less number of grannies to be present, or the grannies which have less condition, we want to invite them first. So let's sort that. So we have 1, 4, 5, 5, 9. So basically we have these grannies, and this granny requires 1, this granny requires 1, this granny requires 4, this granny requires 5, this granny requires 5, this granny requires 9. Now uh, or let's leave it for now. Let's look at one more example. So suppose I have 1, 9, 9, 9. So these are the grannies, and these are the grannies. And initially for this test case, suppose we have 1999, and so initially, like always, there will be one granny in the courtyard, which is Maria. So she'll always be in the courtyard. Now we get the first granny and we invite her. So she will come because already one granny is there, and that's greater than or equal to her condition. And we invite this granny and this granny and this granny. So we can invite all of them together. So at the time of joining, how many grannies will be there? Four. Because if we invite all of them together, then the time of joining, four grannies will be joining. So for each one of them, there will be four grannies. Why? Because for this, there will be these three joining and this. So this can come. But for this, four grannies will be there, one in the courtyard and the other three joining. But this granny requires nine, so she won't be able to come. So in this case, we can only get one granny. So what is going on here is simple. Like we already sorted it. Now what we're doing is we're inviting all of the grannies at the same time, because that will give us the maximum value of the grannies joining at a time. So I invite this granny, and so now the number of grannies joining are the number of grannies already present are one. So in the courtyard we have one granny, which is Maria. So I invite this granny, so one is there. Now invite this granny also at the same time. So 1 plus 1, 2 will be there. So for this, it is greater than the value, so this will be able to come. So at the same time, we're marking who will be able to come. So we invite this granny, and she'll be able to come because the number of grannies present are greater than equal to her condition. So this she will be able to come. So star. Now we look at this granny, and again for her two grannies will be there, because this one will be joining and one is already there. So two will be there for when she arrives. So can she join? Yes, because two is greater than her condition. So she can join also. So star. Now we come here and we invite this granny. And so now the total number of grannies there will be the earlier two and the one there. So three. So can she join? No, she cannot join. So let's mark this as this. Now we invite this granny, and so now the granny joining will be 4. So can this granny join? No, she cannot join. So we'll just mark this as this. Now we come to this granny, and this is important. So when this granny and all of the grannies are invited at the same time, including this granny, so how many grannies will be joining? So the previous 4 will be joining at the same time, and the one already there, so 5, which is greater than her required. So she will be joining. So this is star. Now we invite this granny also, and so she sees that how many grannies will be there? 5 plus 1, 6, but that is lesser than her required condition, so she won't be joining. Now, the last granny who would join, all the grannies before her would be able to join. Why is that? Because she's able to join, meaning that before her the condition is lesser than or equal to. Why? Because we've sorted this. So the last granny who was able to join, all grannies before her would be able to join. So this granny will also be able to join, and this granny will also be able to join. So what we do is we sort it and we find the last granny who can join, and all the grannies before her can join too. So that is what we're doing. So I'll just show you my code. So what I'm doing is I'm taking in the value n and then the array which is showing the value of the conditions of granny. Then I'm sorting it. Now sum is the number of grannies that will be there, either joining or already there, the total number of grannies. And last is -1. So as I said, we have to calculate the last granny which will be joining. And so we're starting from the 0th position. So if sum is greater than equal to her condition, then that granny will be joining. So last will be that granny, and then we'll increase the count. So we can invite this granny also. And then again, we move on, we keep on incrementing, and we look at the granny and we look at the number of grannies invited, and if she can join, then we mark that as our last index. And finally, we see out, we answer last plus 2. Now why last plus 2? Because if the last granny is this, then the total number of grannies coming will be last plus 1, and 1 is already there, so last plus 2. So the total number of grannies in the courtyard will be last plus 2. So that's all we had to do. We simply had we simply invited all of the grannies at one time, and whoever was able to come, we marked them as the last. And the last granny who was able to come, all before her would be also able to come. So I'll give a link to my code in the description. You can check it out. So that's all. Thank you.